there you can see everything out to chapter 4. So next week, Friday, is your chapter 4 test. There's really not a whole lot left. So we have 4-5 tomorrow, which is about as crazy as it gets. I'll just say that. So 4-5 tomorrow, and then 4-6 and 4-7 are basically the same thing. Okay. So like when you are done on Monday with 4-6, you're basically done with everything. Yeah. So you're gonna see for this chapter, we got our quiz number 4 on Friday. We have a quick solve, and we have your homework packet. So the quiz and the homework packet, we're making due on that Thursday before the test. Okay. The quick solve, I would love it on Thursday if you finish it in class, but I also realize you might not finish it in class, so I will accept that on Friday. But that's the only thing I'm accepting for full credit on Friday. Okay. So everything is going to be due on that Thursday, the 20th. Make sense? All right. Our lesson today actually just is talking about terms. How does graph turn? It's pretty short. It's pretty sweet. And I'm just going to draw a bunch of stuff here. So I have a line. How many times does that turn? Does it ever turn? No, it's always decreasing or it's always increasing. So a turn is when you go from increasing to decreasing or decreasing to increasing. So that never happens with a linear function. So the most number of turns and the least number of turns is the same. It's 0. So it's 0 for both. So we're going to kind of try a few things out and just see if we can develop an understanding of a pattern that's going on. And then we're talking about the y towards the end. So it's 0 for both. 2, degree 2 is a quadratic. So something like this. Or something like that. How many times does it turn? Just once. Yeah, this would be my turn right here. So it turns once there, it turns once there. So that's the most turns that it can have. It's also the least number of turns it can have. So we had an odd function, we had 0. We had an even function, we had 1 turn. We're going to see how that keeps going. So now we're at 3. So degree 3's could look like this. It could look like that. Or it could look like that. So let's talk about the first graph on the left here. How many times does this thing turn? 2, right? Because there's 1 turn, there's 2 turns. So this would be the most number is 2. If we look at the least number of turns, does this thing ever turn? It's got a curve in it, but that's not a turn. So the least number would be 0. There's going to be no other possibilities at this point. So I'm just going to say, degree 3 and degree 1 share 0 as a possibility. It has nothing in common with degree 2. When we look at degree 4's look like this. They also can look like that. How many turns does the first one have? 3. 1, 2, 3. So that'd be the most that this could have. The least number is going to be just 1. So now, notice that degree 4 and degree 2 both share 1. There's going to be no other possibilities. It's going to be the last time there's no other possibilities. Degree 5. How many turns does my first picture have? Has 4. What about my picture up here, top right? How many turns does it? It doesn't have any. It has 0. So it has 0. What about this middle one? 2. So, degree 5 also has the same as a degree 3 and degree 1. Okay, now we're going to keep going. Degree 6. Now I got some drawings to do. That'd be 1 option. Obviously, you have the positive and negative of both of them. How many times can this thing turn? 5. What about that one up there? Just once. Yeah, all right. So once, could I ever get it to turn 0 times? No. If I look at other possibilities, what is this going to be? How many times does this turn? 3. 1, 2, 3. That's fine. So it turns 3 times. Okay, let's check some things out. So really, I hope you notice that even and odds, they go together. So the evens do one thing, the odds do one thing. So if I look at the evens, so if I look at 6, 4, and 2, the number of turns that they have is always an odd number. It's 1, it's 3 and 1, 5, 3 and 1, right? So there's a lot of options there. What I do want you to also realize, if I look at the odds, it goes 4, 2, 0, it goes 2, 0, and it goes 0. Notice how they count by. They count by 2s. So if I have 10 turns, I could also have 8. I could also have 6. But you can never have 10 and then 9 turns. You would have a different function. Okay? So why do we look at this? We look at it because, and I'll let you put this in your own words, but we looked at end behavior. Now we're starting to look at what happens in the middle of that function. So we looked at the ends. Now we're starting to look at the middle. So we're getting a more full picture of what the heck we're actually looking at. Okay, so we're getting the more complete picture of this graph. Okay, it kind of looks like Shrek 2, so I'll leave that there. Question for you. 5x to the 10th. What's the most number of turns I can have? I like 9. Let's look back at our patterns here. So 6 gave me 5, 5 gave me 4, 4 gave me 3, 3 gave me 2. So that's another thing I want us to know, is that it's always 1 less. Okay. So we can always go 9. But then if I asked you to list off all the possible turns, what would they be? It would be 9, then it would be... Let's think about how these turns go. I went 5, 3, 1. I went 4, 2, 0. 3, 1. 2, 0. What are they changing by? By 2. So if I start at 9, it's going to be 7. I could also do 5. I could also do 3. I could also do 1. Could I do 0 turns? No. Okay. So we could go to an even larger number. We could do 81. So how many turns could that have? It could have 80. So it also could have 78. It also could have 76. All the way down to, what would it end at? Would it end at 0 or 1? It would end at 0. All right. That's what you need to know about turns. Okay. We are going to start applying this stuff now. We're going to start applying the turns and the end behavior and some other stuff with 4 or 5 tomorrow. Look at the time right now. We have time to do one more problem. Okay. And it's a box problem. And so on your note packet, in the very back of the packet, there's a blank page. But you might be looking at 4 or 1 as you start working through this. So you might have to flip back. So if you want a blank piece of paper, you can use a blank piece of paper. If you want to use the back of your packet, that's fine. Just know you're going to be flip-flopping back and forth. So I'm going to throw a problem up here. And I'd encourage you to actually work together. Like, talk to someone next to you, compare answers, things like that, and see what you can do. But I'm giving you a box right here, and I'm asking you to write a function that would represent that graph. Now, it does tell you a few things. It says it's 15 inches wide and 24 inches long. So I'm going to put those numbers here. And from that, you actually should be able to write the function that models that. And I would encourage you to look at 4.1, see how the heck did we do that, and then compare. Okay, so I'll give you just a minute and a half. Just try it, just write something down, see if you can get the function. We're going to use the same box for the next 4 questions. Okay, so once you draw it once, you have it. So I'll let you draw, answer what you think the function is, then I'll write it, we'll talk about it, move on to the next. Remember, volume has length times width times height. What does x represent for this problem? Length, width, or height? The height. Okay. So what's this representing? 24 minus 2x. The length. This 15 minus 2x is representing our width. And so this x is representing the height. It represents the height, but it also represents a few other things. That height also represents that little side right there, right? So this is x, or you could say h, because whatever I cut out of the box, I fold that tab up, and that tab now becomes the height of my box, okay? So that's where we have to start. Any questions on that? All right, the next problem, I'm going to write the points out. Use the points you want, but you should be able to determine your max volume and the size of the square. And I'm just going to give you a minute on this, because it's just grabbing information and throwing it on the paper. All right, what's our max volume? 486. I'm going to tack on the units. Okay, so I'm going to put inches cubed, but that's good. As long as you got the 486, you're in a really good spot. So this right here is the max volume. That y coordinate is representing all the volumes that we could make. The 3 is representing what? It's representing this piece right here. It's representing the height. It's also representing, and I'll actually accept two answers here. I would accept 3, or I would accept 9 inches squared. Okay? So when we've talked about this in class, really what I'm looking for is, what's that length right there? That's what that 3 is. Okay? But this takes it a little bit further into the size of the square, which is really 3 times 3. So really it would be 9 inches squared. But again, I will take either answer. All right? Questions? I actually prefer this answer, but like I said, I would take both. Moving on. So, height, width, and length. So I'm going to just put these points back up here. And based off the last problem, I'm also going to draw a few things in. So try to do those calculations. Think about what we labeled your formula as. Which piece is which? It all starts with the height. How do I find the width? If this is 3, and this is 3, what's the width? I will take 9 for the length. Okay? Oh. Nope, for the width. Yep, you're right. My bad. Yeah, so 9. So when I write this out, I'm going to, formula-wise, what I could do, because, this isn't always going to be 3. Maybe it's like 2.758. Okay, so if it's not a nice number, then what I would do is I would just write 15 minus 2 times whatever that is, which in this case is 3. That's why I say the height is the most important, because once I know my height, I can do the rest. So I got 9 here, and then I'm going to have 24 minus 2 times 3, and I get 18. And then I'm going to throw my units on as well. The height is always, yep, that number. Pretty much. Yep. Pretty much. That's good. All right, does anyone need more time to write that down? Otherwise, we have 2 other things to do. Domain and range. Domain and range. It is in 4.1, so flip to 4.1 if you want to see it, how we wrote it down. I'll tell you right now, we used some inequalities. I'm not going to say which inequalities we use. There's kind of a hint there. And then domain and range, at least identify is it X or Y. Get that stuff down. Domain X or Y? X. Yeah, that's right. So domain is X. So I'm going to throw an X right there. And there's two actually ways to write it. I've shown you one way. I'm going to show you another way now. So one way of writing this would be X is greater than 0 and less than 7.5. Okay. Now, if you look at the volume right there, it's 0 and it's 0. Do you have a box if you have 0 volume? No, you just have a sheet of paper or a sheet of metal, whatever. Okay. So I don't include that. I don't have an equal. The other way of writing this would be to write it like this, 0, 7.5. And so this is what we call interval notation. Okay, so you have inequality notation, interval notation. Now I use parentheses if I am not equal to something. I use brackets if I am equal to something. So that's an option if you like. Basically all you do is that's my start, and that's where I stop. And so my domain starts right there and stops right there. Okay, so that's one way of looking at it. You can use that if you like. Honestly, I prefer that way. I think it's way easier. Some people like the inequalities, and we want you to get used to it, so it is what it is. Range deals with Y, so I'm going to throw Y in here. This goes from 0 all the way up to that 486. So it looks like this. Why did I put an equals bar on the bottom of that one? Because it's at 486. I can actually make that box. Okay? We can have a volume of 486, and like we will cut out our little squares out of the corners and fold those tabs up, and we will get that. So that's why that's there. And if I was going to write this in interval notation, it would be 0 to 486 bracket. And the brackets, again, because we have the equal to on the inequality. That's how you differentiate between the two. Questions? Last thing I'm not actually going to have you write down. Last thing we're just going to talk about. End behavior. As I go to the right, where's that going? Up. So, reminder, up and to the right are positive infinity, down and to the left are negative infinity. So I'm going to put positive infinity. As I go to the left, where's it going? Down, so negative infinity. Questions?